Hello and welcome to Spectacular Science GAC Attack. This video is not only about making GAC, but also understanding the science behind it, specifically about monomers, polymers, and macromolecules. So in order to teach this, I have my little example students here to help me out. They're going to help both by answering questions as well as helping with the activity that goes along with teaching this principle. So my first question, who here likes Legos? You like Legos? I love Legos. You know something I love about Legos is that I have seen Lego creations as big as a person, actually even bigger than people. And the amazing thing about those Lego creations is that they are all made from teeny tiny little building blocks. No matter how big they all come from little bitty building blocks. And did you know that everything around you is just like that? From this table to the person standing next to you. It's all made up of teeny tiny little building blocks. So small, so tiny that your eyes can't even see them, but they're there. So just about everything around you is made of building blocks that we call molecules. Now I will pause here for just a minute. Older students and the adults watching this might have caught that I said just about everything around you is made up of molecules. Now the reason for that is because obviously there are things around us made of pure atoms. Atoms build molecules, make up molecules, but some things are just pure atoms around us, one pure element. However, in case you're teaching younger people, that will have a lot of new terms in this presentation. We're going to go ahead and simplify and say that just about everything is made up of molecules. Now if you have older students and they ask you, because they've heard of atoms, you can say, you know, that's right, atoms make up molecules. And it's a good time to bring up the point that just like Legos, there's a lot of different Legos, right? But there's still a very specific number of different types of Legos, from square to rectangle, the different colors. So there's a lot of different types, but there's a limited number of your types. And atoms are the same way. There's only a certain number of types of atoms. So that's an interesting connection to make and to explain to kids if they bring up the atoms versus molecule question. However, if they don't, then we can continue by simply saying just about everything around you is made up of molecules. This is how we draw molecules. Can you see here? Now they're so tiny that you can't see them, so it's kind of hard to draw them. But we draw them this way to get the idea of what they would look like. And if you have molecules in a long chain, those are called monomers. Can you say monomer for me?
Monomers.
Monomers. Very good. Now, I want you to imagine something. You see my little bucket here of Legos? Remember how we said that molecules are kind of like Legos? They're the small building blocks? I want you to imagine, what if I dropped something into this bucket of Legos and suddenly all the Legos magically stuck together? Just by dropping something in it. Would that be pretty cool?
Yeah.
That'd be amazing. Do we have anything like that?
No.
No, not really. Not with Legos. We don't have it with Legos, but there are certain molecules that do work that way. There are certain molecules that if you add the right thing to them, if you add the right thing to those long chains, those monomers, then what happens is those monomers form connections. It's almost like they're shaking hands and holding on. They connect and they kind of attract and hold on to each other. It'd be just like if you dropped something in and suddenly lots of your Legos connected like this, all at once. And that's what happens for certain types of molecules. You add something, the right chemical, and those monomers will connect or attach. Now what happens when they do that is they get really big. They go from being monomers to being polymers. Can you say polymers?
Polymers.
Polymers, very good. Polymers are great big groups of the monomers, and they're kind of all stuck together, and they're big and they don't move as much. They kind of get tangled up together. And that's exactly how you make GAC. You start with something more fluid or liquid, your glue, and then you add a special chemical, in this case borax, and that causes your monomers to connect. And then they go from being long and fluid and being able to move over each other to suddenly being all tangled. And that's why your GAC gets all solid. Now if you leave it for a while, well then they still kind of tend to ooze around each other and kind of straighten out. But if you're moving it around and you're playing with it, then they get all tangled up because they're great big giant polymers now. and they become nice and firm and strong. Now, it's kind of hard to visualize that, so we're going to play a game. And this game is going to help us see how that works. This is called chain tag. So we have a nice small area here. Now this you have to experiment a little bit with your number of kids and the space you have. But in chain tag, we're going to start with somebody who's it. Who wants to be it first? Oh, I think we're going to pick a small person. Let's have Julia be it first, okay? Julia, you want to run around and tag someone. Now this game of tag, when you tag someone, you have to link arms. And then both of you are it together. Okay? All right, ready, set, go. Oh, you have to stay in the spot. Oh, she got Nancy. James, you got to stay in the chairs.
Here we go. This time let's go.
Oh, you got Victoria. Oh, now you're chained. Come on, James, you got to be here. Uh-oh. Now it's getting harder to get away, isn't it? Come on, James, you got to stay inside the chair.
I got Aubrey.
They got Aubrey. She doesn't count. Okay. Oh, you got James.
Link. Come on.
And now there's not much of a place for me to go because you guys are great big tangled. Oh, he got me. He got me. Okay. So now we are formed like a polymer, a great big tangled up chain. Is it harder to move around?
Yes.
Yeah, it's not so easy. This is the polymer. Now let go and move around each other. This is like the monomer. This is the glue before you add the borax. Now, add the borax to make the GAC. And now we're more like the polymer. We kind of get stuck. We kind of get tangled. All right? And that's how GAC works. Just like that.
I want to do it again.
You want to do it again? How about we make some GAC and we see how it works on a chemical level. All right, so time to make our GAC. We have dismissed our helpers because apparently kids really love GAC, and it's nearly impossible to make it without having tons of hands wanting to just touch it and stir it and be a part of it, which is great, although not as good for the demonstration. And so we have dismissed the helpers, but we're going to show you how to make the GAC. Now there's a lot of different ways, a lot of different recipes. This recipe is to make more firm, solid GAC for a couple of reasons. For one thing, it's a lot less messy. And for another reason, it really shows the science we've talked about of the monomers making those connections, becoming polymers, and going from very liquid and fluid to really firm and solid. So here we have in our little cup 3 tablespoons of glue and 4 tablespoons of water and a few drops of food coloring, any color you like. First thing you're going to do is stir that. You can see how nice and liquid and fluid that is. You can point out here how those monomers are slipping and sliding all over each other to give you a nice liquid, fluid little mixture here. But we don't want fluid. We want those monomers to connect, to form great big giant polymers, and to give us something we can reach our hands in and play with. So in this bowl here we have water, and it's about 1 cup of water, and 2 teaspoons of borax. And trick here is you really want to make sure you stir until it's all nice and dissolved, otherwise you're just adding water and making it more fluid instead of adding that chemical that causes those cross links, those linkings to happen and give you your GAC. So we're going to do 1 teaspoonful at a time here. We put it in and then you want to stir hard and fast. And already, even with just 1, you can start to see those cross linkings. You can see the polymers forming. You can see it getting more tangled on each other. Now we're going to do another one. And you can do 1 at a time, or you could do 2 at a time. I usually keep it to about 1 at a time, but we're going to go ahead and do 2 now. 1, 2. And you'll do 1 at a time if you want to really get just the right consistency, because the more you do, the more cross-linking. And you want to stir it hard and fast. And that also really helps. You can see already got a really good solid GAC here. And I'm going to go ahead and take that out of the cup. I'm going to stir it around a little bit, play with it a little bit. And you got a pretty good GAC here. So this is, again, not your most fluid oozing GAC, but it really shows the science that we're looking for. It's also really fun to roll and to play with, but it also shows, like we talked about before, that if you give it time and leave it to rest, you can see those polymers will still slide over each other, and you'll still get a nice oozing gack. So you can still see that science at work too, and the kids can kind of stretch it and see what it does. Okay. Now, if you do want it more oozing, there's a few things you can do. We could have done 3 spoonfuls of our borax mixture instead of 4, and it would have oozed a little bit better. This is chemistry, this is science, and since we don't get perfect exact measurements every time, and conditions are a little different each time, it'll be a little different every time, and that's part of the fun, is experimenting with it. So I'm going to show you the gack I have from some other experiments. This is one where I did 3 tablespoons of water and 3 tablespoons of glue. So I did equal glue to water. And here you can see this is even more firm. So this guy is a little bit nicer on your carpet and your clothes. It's still a glue base, so you still don't want to leave it on anything. But if it accidentally falls, it's not going to be as much of a problem. And this holds its shape a lot better. If you leave it, however, it will also expand. So this is equal water to equal glue. You get just a little bit more solid of a firm, more firm and more solid than our mixture over here that had 4 tablespoons of water and 3 tablespoons of glue. So there you can see kind of the difference. This one oozes a little faster and it sticks to you just a little bit more. Now, if you want to go the other extreme and you really want to see the oozy stuff, we have something I made earlier today. Now this one was made with 4 tablespoons of water and 3 tablespoons of glue. However, the borax mixture was 1 teaspoon borax to 1 cup of water. And if I'm being honest, I was not as patient and it did not dissolve as completely. And so you get a much, much more oozy, goozy gack. So this can be fun if you're trying to show the idea of how if you're not holding it, the polymers will slip and slide over each other more. It's because there just is not as much cross-linking in this because the borax is not as strong. And there you can see very oozy, very goozy. Now if you're doing this with a large group of kids, this could be a very large mess. And you can see it sticks to your hands a lot more. So when I had my kids experiment with this, they loved the way this looked as long as I was the one holding it. They didn't really like having it stuck to their fingers all over the place. And so it's fun, and it kind of really shows that slimy movement, that fluid movement when there's not as much cross-linking. But it's a little more fun to play with the other one, and it's definitely less messy. Now it's interesting that that same recipe also made, messy, same recipe also made this gack. And this you can tell is a lot more firm, holds its position a lot more there. It's very similar to, I think, this red one that we just made. Okay, so it's the same recipe, however, just kept adding borax over and over again and stirring harder and stronger and more until it became firm like this. So you could just continue to add borax until you get the consistency you want. However, it took at least 5 minutes to get this consistency, whereas it took about a minute to get it with this, with the higher level of borax. All right, so there's your different varieties, but all with the same very interesting science of the monomers connecting and be forming polymers and macromolecules. Thanks for joining us.